Hi, this is Mrs. Pullen again. This is Unit 3, Lesson 2, and it's the second video on this lesson. And I'm going to talk to you a little bit about repeated zeros, which we had discussed in Chapter 2. A repeated zero is in the form of x minus a raised to some sort of power. And here's an example. And the way this operates is to find the zero, we would just set what's inside the parenthesis equal to 0. So in this case, our root is 4. And we see whatever that exponent is our multiplicity, which in this case is 2. It turns out that the multiplicity, whether it's odd or even, gives us a lot of information about the graph of that function. And it turns out that when you have an even multiplicity, the curve or the graph is going to just be tangent to that x-axis. It's only going to touch it or bounce off it, or sometimes we say it kisses the x-axis. So there's more than one root here. It's going to actually be either 2, 4, 6, depending on whatever the degree of the original function is. When we have an odd multiplicity, as in this case, and again, to find that root, we're going to set the inside of the parenthesis equal to 0. And we can see that the root of the equation is -1. And the multiplicity is whatever that exponent is, which is 3. And that also gives us information. When we have an odd multiplicity, then the curve is going to pass through the root. In fact, if it's an odd number greater than 1, it's going to start flattening out, and we say that it hugs the x-axis at that point. So here's an example. I'm looking to find the number of zeros for a third-degree polynomial, meaning that the maximum number of zeros is 3, and that's important. And here I have one root, but you see how it's tangent to the x-axis here? That means there's actually 2 roots at -1. So we actually have a total of 3 real zeros, even though they're only 2 unique numbers. Here's an example of a problem, and this could be a little tricky, but this was on multiple regions. This is just one example. And they want you to determine, based on this function, which is the potential graph. And you can't just stick this into the calculator because they're letters. Well, first of all, they tell you that A, B, and C are all positive. Well, if A, B, and C are all positive, let's get some information here. You see that -a? That means that that leading coefficient is negative. We also know that the degree of the polynomial is going to be x times x squared or x cubed. So we know we have an odd degree, and we know that our leading coefficient is negative. Therefore, the end behavior is it's going to rise to the left and fall to the right. Well, that helps us eliminate choices 3 and 4. So now we're down to the other 2. Well, let's get some further information. I know that I have one root at -b if I set x plus b equal to 0. And I can rewrite x squared minus 2cx plus c squared as x minus c times x minus c, which is equal to x minus c squared. That tells me I have a root at positive c, and its multiplicity is 2, meaning it's going to kiss the x-axis or bounce off at that point. Well, we could see that's true here. You see how it's bouncing off, and here it's crossing at -b, and so therefore choice 1 works. So here's example 6, and I want to graph this whole thing out. So to start off graphing, we first want to find the degree of the function, and if I take x times the x squared, I see that that leading coefficient is going to be 1, and my degree is going to be 3, meaning I have an odd degree, and I know that my leading coefficient is positive, Therefore, my end behavior is going to be fall to the left and rise to the right. My roots are 1, x is equal to 1, with a multiplicity of 1. That means, based on the rules, which you have to memorize, it's going to pass through. And here, I have a 0 at 2, or a root at 2, with a multiplicity of 2, meaning it's going to bounce or kiss the x-axis. The other information you need to graph a function is the y-intercept, and you get that by substituting 0 in for x. That's how you find the x-intercept. I'm sorry, y-intercept. So this is equal to -1 times +4, because -2 squared is +4, and that ultimately equals -4. And we're going to use that information to graph this. So my y-intercept is -4, and I just want to make sure. My roots are 1 and 2. So I'm going to have my function and the end behavior, it falls to the left and rises to the right. So basically what happens is the function is going to pass through at 1 and then bounce at -2. And here's the sketch of my function. Now we can't really figure out how high it goes. You would actually need to use a graphing calculator or calculus in order to determine that. I hope this helps.